what is exactly calculus? If I had to say it, give a description for calculus in just a few words, it would be rate of change.
Yeah,
That's it.
for sure, for sure.
I mean, there are more things that you learn after you learn about like limits and derivatives, but everything in calculus is pretty much a limit. I think what have we
Yeah.
done that is not a limit?
If you think about it, it can all be represented in terms of limits. Yeah, and I think
Yeah.
rate of change is like the perfect phrase to describe calculus if you're just saying it like just describe it in one phrase. Because at the end of the day, like all of calculus just depends on how one variable is changing with respect to another. That's basically the entire idea of calculus, right? Like when it comes to
Basically.
derivatives, it's one variable divided by another. When it comes to integrals, it's multiplied and stuff like that. So it's all about just how they're changing, and that's the whole deal. That's the whole deal. So at the end of the
Right.
day, I think the roots, the foundation is pretty basic, even though it can definitely get very complicated.
Why do we need calculus? Right? So
Yeah,
calculus is a big one because it really provides results for things that you just can't do without
True.
analyzing limits
true.
and without looking at very small quantities and very large quantities. And I'm talking about, as you're looking at the result of a function or a change in the function as your value gets very, very small and then, infinitesimally small or infinitely large. So, for example, how about this? You drop a ball from, 1 meter, let's say, and you can ask yourself, okay, what is the average velocity of that ball? Well, you can just calculate the time it takes for the ball to hit the ground and, divide 1 meter by that time, and you'll get the average velocity. But you know that when you let go of that ball, it's not moving, right? You need some interval of time to pass before it starts, gradually accelerating. And by the time it hits the ground, it's going very, very quickly. Well, here's the question that calculus kind of asks in an indirect way. It's, okay, well, what about halfway through? Halfway through the descent, how fast is it moving exactly at that point halfway through? And you can ask yourself, well, you can calculate the average velocity of, it moving half a meter, and then the average velocity of the second part of that descent. And then if you just keep cutting that distance down to get closer and closer to just a single point, and then you might ask, well, you can't really calculate the average velocity over a single point because then you're dividing by 0. And so that's when limits come into play, where you ask, well, I can take the limit as that distance goes to 0, but I still get a result, right? It's kind of weird when you've never done calculus before, but that is something that happens. You take the limit as the distance goes to 0 and you still get a finite velocity. So it's like you're dividing by 0, but you're not, because the time it takes also decreases.
Exactly.
And so then you're just doing like a rise over run with very small values, but that ratio is what you're looking for, right?